In today's video, we're going to look at a processing amp, or a Proc Amp for short. Now, what a Proc Amp does is allows you to adjust your parameters of video, like your video gain, your black level, chroma saturation, and the subcarrier phase, or the hue, as it's sometimes called. It allows you to correct video that may have been recorded incorrectly with the incorrect luminance or black level set on the camera. Now, this is not going to adjust white balance. That's completely separate. This is your chroma level and your subcarrier phase that you can adjust with this. Now, to set one of these things up correctly, you need a vector scope. So you've got your reference. This is a consumer level. This is not a broadcast piece, this one, and apparently it doesn't work. So the guy that owns this is a piece he would like back. So I told him I would look at this thing and take a look at it, and gave me a few other pieces, donated a few other pieces for the cause. So I got a few more pieces to service here, but we'll take this thing apart and just take a look at the internal workings of this thing. And I might even go and bring down my Tektronix waveform monitor so that we can actually look at this thing on a professional piece of broadcast equipment for measuring signals. But anyway, here's the board on this thing. This thing might have been made in the States. Sign Video Limited, US patent numbers. But this might have been made in the States, actually. Does it say where it's made? Yeah, made in USA. Cool. I could tell that without even looking at that, just by looking at the circuit board, because look at the board. It's beautiful. I mean, this is typical of an American design product and an American made product. The manufacturing of circuit boards in Canada and the United States is pretty much beyond compare. Everything's really well laid out and everything's logically laid out, but it's just the soldering is pristine. I mean, they really do good work on electronics. This unit here apparently has a couple of problems. I think he said the S-video inputs and stuff is not working. So I'm going to just take this board apart. We're going to take this unit apart, and I'm just going to give it a good inspection and see if there's anything obvious like connectors and stuff that have come loose. Part of the problem with S-video is that they had a tendency to break free. But we'll run this, put it through its paces, and I'll put some color bars into this thing, and we'll look at the input and the output, and I'm going to look at it on a scope. And again, my vector scope is not working at this point. There's an IC that's popped on it, so it doesn't work properly. But my Tektronix waveform monitor does work, and we can certainly look at the levels on a calibrated Tektronix waveform monitor. So I'm going to go grab my waveform monitor, and we'll get that set up in here, and then we'll get this thing hooked up. What this does is this is basically a scope. It's just an oscilloscope, but it's a special purpose scope. It's calibrated, and it's calibrated to display video signals. So let me put some color bars into this thing so you can see what color bars look like. So there's the scope connected to my color bar generator in my camera. And what we're looking at now is we're looking at the flat waveform for standard color bars. Now right now I'm not running into a terminated load, so I don't have this plugged into a monitor or anything yet, but what I'll do, because without termination my levels are not going to be correct. There we go. That's a little more like it. Okay, now I can put this thing into calibrated mode. So if we look at our stair step, this is in flat mode, or not flat mode, this is in IRE mode. Sorry, flat mode is what I had it in before. What we're looking at here is we're looking at our 80% white, because we don't have a 100% white on this color bar source. This is full field color bars. So there's our standard color bars, full field. There's my cat. And what we're looking at here is starting with our white, which is 80%. And then the yellow, cyan, green, magenta, red, and blue. These are your levels. This is the burst level here, and this is the horizontal sync. And our baseline here is at 7.5 IRE, and that's exactly where it is, 7.5. Our sync is on our sync reference here. If I look at other modes of display, if I add the chroma in, see, this is where you end up with 100% for your video level, because the yellow chroma will actually bring our levels up to 100%. On the chroma scale, because the chroma is added to the video. So we can look at chroma and video together. This is our composite video signal. We can filter out the chroma and just look at the luminance. We can look at just the chroma portion itself, And then we can look at what's called the differential gain, which is that one. This is the differential gain between each of the two subcarriers. So it basically expands the chroma. And then we can look at it as a two horizontal line sweep. This thing obviously, oh, what happened there? I just lost sync there. What do you expect? This thing's like 40 years old. We can look at two lines of horizontal sweep. We can look at one line of horizontal sweep. Now we're looking at just the color burst, and with my position control here, I can actually look at one line of video at a time. Normally we have it sitting here on the front and back porch, and as you can see, this control is very dirty. Again, because this hasn't been used in a long time. We can look at a two vertical line magnification, and this is where, if we look at this is the where we would find macrovision hiding right in here. That's the vertical sync area. This control needs some attention. It's very dirty, as you can see. And then we can look at two full vertical sweeps. So here's field 1 and field 2. So you can actually see the video signal itself. Anyway, I brought this down for demonstration because I want to plug this processing amp in so that we can actually look at what a Proc Amp will do to the video signal. That is, if this Proc Amp actually is going to work. So that's why this is here, because it gives me a little more accurate display than, say, using a regular oscilloscope, which is not calibrated. This is an NTSC broadcast piece that was calibrated when I got it. It's probably no longer in calibration or certification because the thing is very old. But let's take a look at this Proc Amp and see what it does. So plugging it in, I don't have any signal through it yet until I turn it on, but when I turn it on, I get signal through it. Now we can immediately see that the gain is completely different on this thing. If we're looking at it on the scope here, even when this is set to unity, well, it's actually turned down a bit. Let's just turn this up here. Okay, so there we go. This is where we can adjust. These controls are dirty on here, by the way, but if I show you the monitor so you guys can see exactly what I'm doing, this is what a processing amplifier does. Those controls are in bad shape. They need to be cleaned. But, well, first of all, we can put it in mono mode, which is supposed to actually turn off the color, but it doesn't. And all it's doing here, if we look on here, is it's supposedly turning off the color burst. But as you can see, my monitor is still running in color. There's still enough signal leaking through there that it's not actually turning it off. Split screen. Okay, it gives me a split screen so that I guess this is so that I can this is so I can see what I'm doing. If you look on the scope here, you can see I'm changing my black levels here, and if I change this one, I'm changing my video levels. And you can see it on the screen there. This is to give the person who's playing with this unit that doesn't have test equipment an idea exactly as to what they're doing to their video. So you can really mess it up if you really want to. So as you can see with the split screen, now this is supposed to tell you here what your video levels are and if you're clipping. Now let's see if it does anything here. Okay, so when you're not playing around with the split screen, this video level gauge here is supposed to tell you where your levels are and whether you're going into clipping. But as you can see, I'm well into clipping before it even lights up. I'm way up there. If I put this into IRE mode to get rid of the color, I'm way over 100%. In fact, I'm at 100% right there. And on the black level side of things, if I'm turning down the black levels, well, now it's telling me that I'm at 5%, but my black level is actually crushed. My dark blue bar is right down at 0 before this is even telling me anything. And if I continue to go down, well, it won't even let me go down to clipping. Ideally, you want to set your level up right about where unity is. That's about the right place. And that's basically going to show you between about 20 and 60%. So this video level is useless. Now as far as the chroma goes, well, we can look at this in full scale. Now if I had a vector scope, we'd actually be able to see the vectors going up and down. But again, same thing. You can turn the chroma down, although when you turn it down, look at the picture, it's not really taking the chroma out. It's got a cyan, a green, a magenta, and a blue line in the screen. It's not really doing much. You see the spikes of color here that are still there. If I flip this over to chroma, well, there's still some chroma here. That should be zeroed out. And then differential. Now what happens if I hit mono? Will it take it? Nope, still doesn't. In fact, if I put this in mono mode, so I have a feeling what the mono on this is for is if you are feeding a monochrome signal through this unit, you can defeat the color processing, and because I think this unit here probably is going to create a new color burst signal no matter what. It's going to generate a new color burst signal. So if you feed a black and white source into this thing, it probably is going to generate a signal. I can try that. I have a black and white camera I can plug into this just for the heck of it to see if it's doing what I think it's doing. It's going to generate a color burst on a black and white signal. Okay, so it doesn't generate it. And incidentally, that camera is, I've got a rat trap up in my attic because I found a rat up there. And incidentally, this rat trap neutralized the threat. But I found a rat had gotten into my attic space a couple of years ago. So I stuck an infrared camera up there just to monitor the trap. And now I just turn it on and check it once in a while to make sure that there's nothing in there. But I haven't had a problem with a rat since that good old Victor trap neutralized the situation. But here we can play around with this device here, looking at this picture because it's actually relatively dark. And as you can see, I can bring the gain way up on this thing and actually distort it. But we can bring the gain up and we can turn down the black. So what a Proc Amp is for is if you've got a bad video source, you can compensate when you're making a recording of it. You can compensate for levels that are incorrect, that were incorrectly recorded. You can bring your gain up. You can adjust your black levels to compensate for it. But to do it, you need a vector, or not a vector, well, a vector scope would be great too, but you need a waveform monitor in order to do this, to calibrate it, because you need to see exactly what you're doing. Otherwise, you could crush your blacks like I'm doing here, right? You want to ride your black levels at about 7.5 IRE over the baseline, and you want to try and bring your video levels to the point where you're not exceeding 100%. So something like about there. And if there was chroma, well, you would adjust the color level too. But as you can see this here, where the you can see some noise there where the burst would be, but there is no burst of a black and white signal. Except for if you look at the screen, if I crank up the saturation, I'm bringing the noise up because it's trying to amplify signals that aren't there. Even though there is no burst, therefore the TV is running in black and white mode, this thing here is trying to bring up the level. Let's go back and look at the color bars again. So now we're looking at the color bars again. We set our levels up. And again, here's the saturation utility. As you can see, we can oversaturate the chroma or take it down to nothing. And that doesn't show up on the level. That's just for video levels. So for chroma, you really need to have a vector scope to do it properly. The color phase will change the actual tint that you can see on the monitor. That's changing. What that is doing, if we look at, I believe that one, you notice what's happening here if I zoom the camera in on the color burst. What we're doing is we're actually changing the phase of the color burst. You see, we're removing the phase here. And that's changing the reference for the demodulator in the TV. Saturation doesn't do anything to the burst level. It changes the actual subcarrier levels for the chroma, but it doesn't do anything as far as changing the level of the burst. It stays constant. I think this is for unity gain, what that does. And it disables everything is what it does. So when you press the unity button, you're effectively disabling all adjustments from this. So you can muck everything up and hit the unity button and it takes it back to the same as putting the controls back to there. So that's what this button does. This is a bypass. So you can completely bypass the thing. Split screen, again, bypasses everything. I still haven't figured out what that mono button is there for. It does take out the burst, is what it does, but there's still enough burst there that the TV is locking in color. I mean, ideally you would think that when you put it in mono, it's going to blank the color out completely, but unfortunately there's enough of the reference there that the TV still locks in on it. Now maybe if I turn off the TV and turn it back on, maybe it won't lock. Let's try that. See whether it'll come up in black and white. Nope. There's still enough signal leaking through that the TV knows it's a color signal. But if you look around the edges of the colors here, if you look around the edges of the color, we've got some serious discoloration when I hit that mono button. You see what's happening? So it's kind of a useless feature. The other button on here is one marked sync. Let's take a look and see what the sync button does. I think it just adjusts the sync level, and that's what it's doing. It's just cleaning up the horizontal sync. And is it doing anything in vertical? Doesn't appear to be doing anything in vertical. What I'm curious is what this thing's going to do if I put a macro visual signal through it. Before I do that though, I'm going to clean up those controls, because I mean these controls are a mess, as you can see. So let's get out some contact cleaner. We'll just give those a spray and see whether I can clean those up a bit. There we go. See, ideally you could hit the mono button and turn the saturation down if you wanted to create a black and white picture, but it's not. It's giving us these thin strips of color, so that doesn't work right. few other things I need to test on this. I need to check out the S-video inputs on it. And for that, I need to grab a device that has S-video output, which I just so happen to have. And it has color bars on it too. Let me go grab my other professional camera. Well, one of my professional cameras. So here's one of my older professional cameras. This is a tape-based HDV camera that I've had for probably about, I don't know, 12 years, I guess now. It's going to put color bars up on this thing. Oh, I gotta go into the menu because it hasn't been powered up in so long that it's going to ask me to set the clock. But this has got a color bar generator in it. It's got a nice SMPTE bar generator, and this camera has an S-video output. So let's plug the S-video output into this thing and see whether this unit will work. And it does. So this one, of course, has got the extra I and Q. So you'll see the I and Q stair steps. These are SMPTE color bars as opposed to full field. So basically, with this setup, with these color bars, this is the type of color bar signal that you would use for calibrating a monitor that has the ability to turn the red and the green channels off. All the professional monitors had that, or you can use the blue lens that you hold in front of your eyes and it just filters the primary color. And how you did that is by turning off the green and the red channels. You would adjust the color saturation looking through a blue filter so that, excuse me, I got somebody that's interrupting me now who just can't wait for me to respond. I almost totally forgot my train of thought there as I got interrupted by some messages. But how you set up a color set using a blue filter, or if you have a TV that you can turn the red and the green off, which some newer sets have that ability in the advanced setup where you can turn the red and the blue channel off completely. And how you set them up is you adjust your color, your brightness or contrast, and your tint controls to make the colors the same, to make the picture look uniform. So you adjust your saturation. Once you've set up your black levels and your contrast, if you look down here, and I can do this showing on this using this the adjustments on the Proc Amp, but you would adjust your black level so that this gray bar here is just black, so you can't see it. So something about like in there, right? And the same with the gain. You can crank your gain up, you can see it. If I crank the levels up, you can see it here. So you adjust your black level so that that is just not visible. That sets your brightness and your contrast. Then using a blue filter, you adjust the saturation so that everything appears the same level. So, because filtering with a blue filter, or looking, in fact, I should go see if I can find a blue filter so I can put it in front of the camera. I don't know how it's going to work as far as the color balance. It's probably totally screwed up, but I might be able to set this thing in fixed mode and then hold a blue filter in front of the lens so you can kind of see what I'm doing here. Maybe I think I might have one. I used to have it. It used to be, there was one package with the Laserdisc, a video standard, and it was used for calibrating. So let me see if I can find that thing and give you an idea what I'm talking about. Okay, this is what I'm looking for, a blue filter. Cool, huh? I'll show you how you adjust the color using a blue filter. So basically what you do is you look through the blue filter and you want to adjust your color and tint controls to try and match the same color all the way throughout the picture. So as you can see, when you adjust your brightness, you're trying to match. Well, first of all, you set it up using looking at the black levels, right? And then what you do is you adjust your color level, looking through the blue filter, what we want to do is we want to match the blue here. We want these levels to be the same, and all these will be the same shade of blue. So if I'm looking through the blue filter here, you'll see the 4 blue stripes. As I adjust the saturation, you will see the levels will change. And what I want to do is I want to try and get the bottom portion of the blue here in the 2 end pieces. So this one and that one, because those are the blue and white references. I want to adjust the saturation or the color control on the TV, or in this case through the Proc Amp. I want to adjust them so that they look the same color. Now they look the same. Then I would adjust the tint control. Watch what the tint control does. The tint control, as you can see, changes the 2 middle bars, but the ones on the edge don't change. You notice that? They stay the same. So we want to adjust the tint so that they are the same intensity. And once we get the tint adjusted so that they are the same intensity, now our color is calibrated. This is how the pros do it. They either turn off the red and the green, which you can do on some of the more modern TVs. If you don't have a modern TV, you need to get your hands on one of these blue filters, which is just a primary color blue. If I point this up at the light, you'll see, it just blocks out all the other colors except for blue. And you can hold this up to your eyes, and it looks exactly the same as it looked on camera. So by me looking at this, if I look through this with my eyes, I can adjust this and I can get it perfect. Just like that. That's how you adjust color using a blue filter or blue only on the TV. When the guys come into your house and they charge you $500 to calibrate your TV, and they chase you away and say, oh, no, don't bother the guys, they're working. Okay? He's putting up color bars either off a DVD or a Blu-ray, or maybe he's carrying around a camera with a color bar generator built in. He's putting up color bars, he's looking through his blue filter, and he's adjusting it. And then for the privilege of that, he's saying, that'll be $500, please. One thing I have noticed about this Proc Amp is that the S-video input might be a little bit noisy, so maybe we'll clean those control, or clean the pins at least on the back there. I'll give them a shot of cleaner. Actually, these ones here, I'm probably going to use the D100 with the needle applicator, because then I won't waste it and I can get it right down into the pins. So I haven't used this bottle of stuff before, so let's just put the cap on here. And I'm going to give the contacts a shot of pure cleaner. This way I can get this stuff right down into the pins without any wastage. That looks pretty good. We'll test the output on this thing as well. I'll just plug into the output side, and this should, if I plug my color bars back into the input, composite input, this should give me an S output which I can feed to the monitor, as this TV does have S-video input on it. A lot of the newer ones don't. In fact, I don't think any new TV's got S-video, but this one does. So when I plug this cord in here, there we go. So now, S-video is working. Might help if I plug it in all the way. So S-video is working on this thing as well. Just how to clean up the contacts on the S-video plug. The Proc Amp will take, now you can tell that this has got a comb filter in it because look what it's doing to the the color here, color bars. If I dig up another S-video cord, which I'm sure that I've got some around here, I should be able to take S-video from the camera and take it right into this, and then we can eliminate the crosstalk completely and just check it out for color purity going through in full S mode. I've got another S-video plug here. We'll plug that in and take off the other one so we're not feeding two signals in at once. And now you can see the difference, right? If we look at the S-video signal coming in, and this will actually give us a composite output as well, because I'm still looking at the composite output on my scope here. But we can process an S-video signal the same way. Going through this little processing amp. Now what happens if I press mono on this one? Get rid of the color? Nope. Oh, if I press the mono button on this, it even gets stranger. Look at what happens to the color when I press the mono button on this one. It really messes it up. And the chroma control is just really making the colors go wonky. Even though I turn it all the way off, there's still there's still enough bleed through that it's removing the burst, but it's not removing it enough. So there's S-video in, S-video out. If I unplug the S-video cord on the monitor here, it'll go back to composite, right? But the 3D comb filter in this TV is actually very good. You're not seeing any dot crawl on here. You saw it momentarily. Watch when I unplug it first. I'll plug it back in. Okay, there's S-video in. Watch what happens when I first unplug it. You'll see a bit of dot crawl for a second, and then the comb filter will kick in on the TV. So there's the dot crawl, and now it's gone. If I feed a composite signal in to the Proc Amp and let the crappy little comb filter in here separate it, watch what happens. We're going to get some interference at first. Okay, now you can see the crosstalk big time, right? That's caused by interference between the luminance and the chrominance signals. And this is not doing a very good job of separating. If I plug S-video in, of course, they're gone. Now they're back. And if I unplug the S-video from here and let it go back to the TV, as you'll see, that's the TV's decoder that is actually decoding the composite signal and breaking it back to the component levels. So the YC separator in this TV is fantastic. You know, this was an expensive, it's a plasma. This was an expensive set when it was new. All of the older NTSC sets, the recent generation, not the vintage stuff. The vintage stuff looked like crap. But the recent generation that had a digital YC filter, or a digital comb filter, did a very good job of separating the color and not getting the dot crawl that we saw when I input a composite signal in this and let this send it as an S signal, because the TV is not going to process it. If it comes in as a YC signal, it is not going to process it with the comb filter. So the comb filter in this thing here is no good. But this little unit works fine. It's a Proc Amp. If you give it a composite signal, you get a good composite signal out. If you give it an S-video signal, you get a good S-video signal out. If you give it a composite signal in, you get a mediocre S-video signal out. This is very much like the YC separation on Panasonic. I'm going to pick on Panasonic here. Panasonic Laserdisc players back in the 1980s. Laserdisc, of course, is a composite format. All the manufacturers of Laserdisc players, you got a standard video output. Panasonic came along, they put an S-video output on their Laserdisc players as a selling feature. And people would buy them. And then they would complain because they say, well, the picture doesn't look as good going through the S-video output than it does going through the composite output on my Sony Trinitron or whatever TV they had. They'd come back to the shop and they'd complain about the picture quality. They'd say, look, I bought this expensive S-video cable and the picture doesn't look as good. And I'd explain to them, well, it doesn't, because you've got a $2,000 TV which has got a 3D comb filter in it and does a very good job of separating the luminance and the chroma signal. And your Laserdisc player, they put in a $10 comb filter, and you're not going to get the same performance. So don't hook it up with S-video, hook it up with composite, and it's going to look fine. Well, then we'd get the arguments from the so-called experts out there that read something in a magazine, because of course this is before the internet, that read something in Videomaker or one of those other stupid rags that said you had to use an S-video, you couldn't use composite was crap, and if you didn't use S-video, and if you didn't buy something with S-video, you know, there was a whole big, in the late 80s and into the 90s, there was a whole big thing about S-video. Everything had to be S-video. And people would hook up VHS machines with S-video, or they were super VHS machines, but they'd hook them up with S-video, and they would wonder why their rental tapes didn't look any better. And they'd wonder why their recordings off TV didn't look any better. And you had to explain to them, the only way you're going to see an improvement in the picture quality is if the source is recorded in a component format. And S-video is a component format. In other words, if you took your high 8 camera or your super VHS camera and you made your own original recording in super VHS or high 8, and you played that back over the S-video cable to your TV, it is going to look better than if you went through the composite video. But if you took that tape and edited it down to, say, regular VHS, you've lost the benefits. If you took that tape and you edited it to another SVHS machine or a high 8 machine using an S cable, yes, you'd preserve the quality, but once it's in composite, you're not going to get that quality back. Anyway, that's this little unit here. I was thinking I was going to pull the board out and look underneath this thing, but there's nothing on the bottom side of the board. There's no components mounted on the bottom. I was thinking initially it was going to be bad solder on some of these pins, but it turns out that all the problem was the pins themselves had oxidated and were not making a good connection with the S-video connector. So a little bit of this deoxit cleaner, D100, with the needle extension, that made getting into those connectors really easy and cleaned it up. And I've cleaned up the controls. The only thing I haven't done yet is I haven't done these switches, and maybe we'll do those as well. And I'm going to do them using this because I can get a drop right into the switch. So as you can see, there's a little hole in the top of these switches here. I'm just going to put a little bit of deoxit into each one of them. And then I can activate the switches. If you want to see the comb filter working on this TV when it kicks in, if I hit the unity switch, you'll see it momentarily. You'll see a bit of, see? That's the comb filter resynchronizing on the TV. Anyway, this thing's fixed. This thing's working. It's doing everything it's supposed to do. The guy that owns it will be, I'm pretty sure he'll be happy to get it back. You see, if I roll the hue control, watch, I can actually make the comb filter get out of sync here momentarily because I'm causing huge phase shifts. But The comb filters on TVs would do that if there was a lot of color changes and stuff, but when they were displaying a relatively static image, they did a very good job. But if there's a lot of, like if I turn the color slowly, it won't do it. But if I create huge phase shifts like this, it takes a second before it locks back in. But that's normal. Anyway, that's this Proc Amp. Hope you enjoyed this look at this. I have a few other interesting things. I'm going to leave the waveform monitor down here because I do have another video. I have a frame store that apparently is not working, and I'm going to be looking at that, and we'll put that through here as well. But anyway, thanks for watching. We'll catch you in the next one. Bye.